Welcome! Today we're going to do some really elementary exercises in preparation to do some calculus, and then we're going to do a little bit of calculus. Okay, let's get started. So the first problems in this set are mostly simplification of algebraic expressions. So question 1, simplify 2b to the fourth b squared. Well, here we need to add the exponents. So this is 2b to the power of 4 plus 2. So we've got 2b to the power of 6. Okay, second question. Simplify 3k to the fifth times k. Well, again, we need to add the exponents. So we add 5 plus 1 and we get 3k to the power of 6. Okay, question 3. Simplify m to the power of 5 over m cubed. Well, in this case, we need to bring the m cubed upstairs to the numerator. And so we have m to the fifth times m to the power of minus 3, and that is m to the power of 5 minus 3, adding the exponents, and so we get m squared. Question 4. Simplify 3s over s to the power of 4. Well, we could do this in a couple of ways. So we could take this s downstairs to the denominator and say that this is 3s to the power of 4 minus 1, or 3 over s cubed, but this is also the same as 3s to the minus 3. So I would say both of these are equally simplified here. Question 5. Simplify x to the power of 8 all to the power of 3. So in this case we need to multiply the exponents. So we have x to the power of 8 times 3, and 8 times 3 is 24. So x to the power of 24. Question 6. Simplify ax to the power of 5. Okay, so this is a to the power of 5, x to the power of 5. Question 7. Simplify 3 over n cubed all to the power of 3. So here we need to apply that power of 3 to the numerator and the denominator. So 3 cubed over n cubed cubed. 3 cubed is 27. Now on the denominator we multiply the exponents, so that's n to the power of 3 times 3. And so we have 27 over n to the power of 9, or we could write 27 n to the power of minus 9. Okay, question 8. Simplify with rational denominators root 10 times root 2. Well, you want to think about the factorization of these numbers. So we can express 10 as 2 times 5s, and so this is root 2 times root 5 and times root 2. Now we have 2 of the root 2's, so root 2 squared times root 5. Root 2 squared is 2, so this is 2 root 5. Okay, question 9. Simplify with rational denominators root 7 times root 21. Well, same story here. We have root 7 times root 7 times root 3, because 21 is 7 times 3, and so that's root 7 squared times root 3. Root 7 squared is 7, so this is 7 root 3. All right, question 10. Simplify with rational denominators 5 root 2 all squared. So this is 5 squared times root 2 squared. So we have 25 times 2, which is 50. All right, let's keep going. Question 11. Simplify with rational denominators 2 minus root 5 times 2 plus root 5. So this is the factorized form of a difference of 2 squares. But if you didn't know that and expanded it, what you would get is 2 times 2 plus 2 root 5, and then minus root 5 times 2 is minus 2 root 5, and then minus root 5 squared. Okay, now root 5 squared is 5, and these two vanish. So we have 4 minus 5, which is minus 1. Okay, let's move on to factorization. So question 12. Factor 7x minus 7y. Okay, what's common here? There's a common 7. So we pull that out, and then we put in brackets what remains when we divide each of these terms by 7. 7x divided by 7 is x, minus 7y divided by 7 is minus y, and so there's the factorized form. All right, let's move on to question 13. In question 13, it says factor 6b minus 24. Well, what's common in both of these terms is 6, because 6 divides 24. What remains is b minus 4, because 24 divided by 6 is 4. Okay, and that was number 13, so we're up to 14. Factor 15x squared minus 3x. Well, again, we look at what's common here. We have a common 3x because there's an x in each, and 3 divides 15. In fact, the greatest common divisor, or GCD, of 15 and 3 is 3. So we have 3x outside of 5x minus 1, because 15x squared divided by 3x is 5x. Okay, question 15. Factorize 90p cubed minus 15p squared. So what's common here? The greatest common divisor, or GCD, of 90 and 15 is 15. So 90 divided by 15 is 6. There's a common p squared, so we'll pull out 15p squared. What remains is 6p, and then minus 1. Question 16. Factor 2x plus 4y minus 8z. Well, each of these has a common 2 in them. The GCD of 2, 4, and 8 is 2. So we pull out a 2. What remains is x plus 2y minus 4z. Okay, question 17. Factor x squared minus 9. This is a difference of 2 squares. So first we can express this as x squared minus 3 squared. And so that's x plus 3 times x minus 3. Okay, question 18. X to the 4th minus 16. Well, again, this is a difference of 2 squares because we can express this as x squared squared minus 4 squared. And so as a difference of 2 squares, we have x squared plus 4 times x squared minus 4. Now notice x squared plus 4 is irreducible over the real numbers. You cannot break this into a product of 2 linear factors with real coefficients. You would have to go into the complex numbers to do that. But this one, x squared minus 4, does factorize over the real numbers because it is also a difference of 2 squares. So let's view it that way. X squared minus 2 squared. Okay, so now we can see how to break it up. So we have x squared plus 4 times x plus 2 times x minus 2. Okay, question 19. Factorize x squared plus 6x plus 5. Okay, now what I'm going to do here is notice that the divisor pairs of the coefficient on the end and the last coefficient, divisor pairs, so I'll write this, of 1, we just have 1 and 1. Okay, divisor pairs of 5. Because 5 is prime, we just have 1 and 5 up to order, because of course we could swap this around, but we'll just consider the single pair in increasing order. Okay, so what we want to do now is work out which one to put with which one, but it's very easy here because we just take 1 times x for one of these ones and 1 times x for the other one. So I put my brackets in first, I put the x in, and then I decide where to put these numbers. Since there's only one divisor pair of 5, I'll just put a 1 here and a 5 here. Next, I notice that 5 is positive, so that means I should put the same sign as I put here and here, either plus plus or minus minus. But which one depends on the sign of that coefficient of x. Okay, so because it's positive, I want both of these to be positive so that the total sum is positive. So I just insert plus, and there's my factorization. Okay, question 20. Factorize s squared minus s minus 56. All right, so again, the divisor pairs of the coefficient of s squared, just 1. We only have 1 and 1. Okay, so we know already that this is going to be 1s and 1s. Okay, now we have to decide what numbers or integers to put here and here. So to do that, we list our divisor pairs of 56. So we have 1 and 56, or we have 2 and, let's see, 25 plus 3 is 28. 2 times 28 is 56. Okay, then now this is 7 times 4, isn't it? So we could have 4 times 14 is 56, or we could have 8 times 7, or 7 times 8 is 56. Okay, so I've listed all of the divisor pairs of 56. So I've got to decide which pair to put here and here, right? Okay, but the way I do that is I look at the signs of this. This is negative, so I want one of these to be plus and the other negative. And so I want the difference to be a 1. Okay, which of these has a difference of 1? So 8 minus 7 is equal to 1. So I want an 8 and a 7. So I put in an 8 and a 7. Now I know one should be plus and the other minus, but I want the sum to be negative. So I want the larger of the two numbers to carry the minus sign and the smaller to carry the plus sign. Okay, moving on. Question 21. Factorize x squared plus 2x plus 1. Now you should just remember that this is a perfect square. It's x plus 1 all squared. Okay, question 22. Factorize 2n squared minus 13n minus 7. Okay, 2 is prime and 7 is prime. So the divisor pairs of 2 are 1 and 2, and the divisor pairs of 7 are just 1 and 7. So which one of these multiplied together? Do I multiply the 2 with the 1 and the 7 with the 1? Do I get a sum or a difference that is 13? No, I don't. So I want the products, sum of the products or difference of the products that gives me 13 or minus 13. So let's set this up. We have an n and we have a 2n. Okay, now we've got to decide where to put the 1 and the 7. So I want the 7 to go with the single n, because if I put it here, then I don't have a way to get the 14 out of it. So I need to put it in this bracket and then the 1 over here. Now that I've got that, let's decide the signs. So the sum is minus 13, and our observation here is that 7 times 2 minus 1 times 1 is 13. Okay, now we need the larger product to carry the minus sign. So the minus there and the plus here. All right, now this can be a little bit tricky, so I'll show you another method to do this using the quadratic formula. And I'll just remind you that the quadratic formula, what it does is it solves the equation ax squared plus bx plus c equals 0, provided that a is not 0. It solves this for x via a formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so that's the quadratic formula. So how can we use the quadratic formula to factorize this expression here? Well, it's basically a no thinking method, right? Because this takes a little bit of thinking to do, and you could potentially have many divisor pairs of each of those numbers, so it could be a very long process to go through all the possibilities. So this can be faster if these numbers were highly composite. Okay, so let's use the quadratic formula here. In this case, we have, so our first step is solve 2n squared minus 13n minus 7 equals 0. That's what we're doing here. And from the solutions to this, we want to generate these factors. Okay, so b is minus 13. So negative b is plus 13, plus or minus the square root of b squared. 13 squared is 169. So minus 13 squared is 169. And then we have minus 4 times 2 times minus 7. And that's all over 2 times 2. Okay, so let's simplify this. We have 13 plus or minus the square root of 169 plus 7 times 8 is 56. All over 4. So we need to simplify what is inside that square root. So let me see. Now I need another 31 to get up to 200. So if I subtract 31 from 56, I have 25. So this looks like 225. Okay, so 13 plus or minus the square root of 225, and that's all over 4. Now 225 is 15 squared, so we have 13 plus or minus 15 all over 4. And we get 13 plus 15 is 28. So 28 over 4 is 7. Or in the other case, 13 minus 15 all over 4 is minus 2 over 4, or minus a half. Okay, so what we found is n equals 7 or n equals minus 1/2. Okay, so we put these together because when we have a root of a polynomial, we also have a factor of a polynomial. So n minus 7, n minus a half, which is plus a half, equals 0. Okay, now that's not quite what we have here, because we need some constant in front so that we can get linear factors. So that constant is the number that we need to make this a integer coefficient linear polynomial. So that would be 2. Okay, and so now let's take that 2 and put it in here, and we get n minus 7 and 2n plus 1 equals 0, which is the same equation as this, and hence we have the factors the same as up here. Okay, so that's another method to factorize a quadratic polynomial. Let's move on to question 23, which says graph y equals 2x minus 4. Okay, so we can see that the slope of this line is 2. The y-intercept is at minus 4. So we have a point down here. And we have a slope of 2, so it's going to be somewhere like this. But what I like to do is I like to find the other intercept also. So when y is equal to 0, we have 2x minus 4 equals 0. Take the 4 over to the right hand side and divide by 2, and we get x is equal to 2. So 1, 2, and then we can just connect the dots. Okay, and there's our line, and you can see that it does have slope 2, so that's all fine. All right, where are we? Question 24. Graph y equals 7 minus 2t. So we've got a slope of minus 2. I put y, but it's s, so I'll just stick with y there. Okay, so when t is 0, we have 7, so that gives us an intercept. Hopefully I've counted 7 there. 1, 2, 3, 4, 5, 6, 7. Okay, now when y is equal to 0, we have, I'll write this out for you. We have 7 minus 2t is 0, so t is equal to 7 over 2, which is 3.5, so 3.5. Okay, so 1, 2, 3, 4, and our half is there. And so we have a line of negative slope minus 2. Okay, moving on to question 25. So in question 25, we are asked to graph y equals x squared. So for a curve like this, I would suggest to you to find several points. So find a few points. Okay, so we have when x is 0, y is 0, so we've got the point 0, 0. We've got the point 1, 1, because when x is 1, 1 squared is 1. Okay, we've got the point minus 1, 1, because minus 1 squared is 1. We've got the point 2, 4, because 2 squared is 4. We've got the point minus 2, 4, because minus 2 squared is 4. So that should be enough to sketch our curve. Okay, so let's fill in our points. We've got 0, 0 there at the origin. And if this is 1 and this is 1, here is 1, 1. Likewise, minus 1, 1. Okay, when x is 2, we have 4. So 1, 2, 3, 4. Another point there. And on this side, minus 2, 4. That would be somewhere around there. Okay, now since the leading coefficient, so the coefficient of x squared is positive, greater than 0, it looks like this. Smiley face shape. So let's fill that in, and it's got a minima here when x is 0. And then it keeps going like so. Okay, question 26. Okay, in question 26, we're asked to graph v equals s cubed. So again, you want to find a few points. We've got the point 0, 0, because 0 cubed is 0. We have the point 1, 1, because 1 cubed is 1. We have the point minus 1, minus 1, because minus 1 all cubed is minus 1. Okay, so that's 3 points so far. Let's look at what happens when s is 2. When s is 2, 2 cubed is 8. So that would be way up here. Okay, and so when s is minus 2, you have minus 8. That's way down here. And now what you might want to do is do a little bit of calculus. Say, for example, what is v dash of s? What is the first derivative of this? Well, it's 3s squared. Now that is greater or equal to 0 because squares are always greater or equal to 0 and exactly 0 when that s is 0. So v dash of s equals 0 if and only if I double f s is equal to 0. It's positive otherwise. So we have a slope that's positive everywhere except for at 0 where it's just for a moment horizontal. Okay, so we want to draw something like that. And it looks like this. Okay, let's move on to question 27 on continuity. Okay, so for which values is the function 6x minus 15 continuous? Well, it's a line. Now, intuitively, the way you can think about continuity is ask yourself the following question. Do I have to lift up my pen ever to sketch this function? And the answer is no. So therefore, the function is continuous. Okay, so the answer to this question is f of x is continuous for all real values of x. All right, but let's give a slightly better definition of continuous. Okay, so dot point 1, f of x is continuous at the point where x is equal to a if the following condition holds. The limit as x approaches a of f of x is equal to f of a. Okay, and then our second dot point, f of x is continuous on the domain x if f is continuous for all x in that domain. Okay, so this says x is an element of the set x. And note, f here would be a map from x to y, where this is the domain and this is the codomain of the function. Okay, so that makes sense here because there's no point here where I have a discontinuity. There's no point where the limit wouldn't match the value of the function on this function right here. Okay, so I'll keep this paper aside and we'll come back to that definition as we need it. All right, so next let's have a look at 27, which says for which values of x, where x is given by 2 over x squared minus 7x, which values of x is this function continuous? Okay, so we have to consider, are there any problems with the definition here? Well, we certainly don't want 0 denominators, so let's write that. We cannot have 0 denominator. Okay, and so when do we get zero denominators? Whenever x squared minus 7x is equal to 0. Okay, we can factorize this, and when we factorize that, we can pull an x out, and what remains is x minus 7. Okay, and so this has two solutions, x equals 0 or x is equal to 7. So what we learn is when x is equal to 7 or x is equal to 0, 0 or 7, f of x is not continuous. At those points, all right? So we'll just say it's not continuous there, but it is continuous everywhere else, because in order to sketch this function, I would not need to lift my pen up anywhere except for when x is 0 and when x is 7. So now that we're here, let's just sketch this function using Mathematica. So I'll write plot two over x squared minus 7x, but we need brackets around this because it's in the denominator. As x goes from, say, minus 1 to 8. Okay, so you can see what happens. We have a discontinuity at 0, so it goes up on that side of it. And also over here at 7, we have a vertical asymptote there also, and it comes down from the top and keeps going. Okay, now in between 0 and 7, it looks like this. So we have a vertical asymptote there and a vertical asymptote at 0. So the function, in order to sketch this function, I have to lift my pen up here once I get to positive infinite, pick it up and come back down to minus infinite and keep going as we cross x equals 0. And then the same thing here, I come down to minus infinite, I have to pick up my pen, come up to positive infinite, and come down and keep sketching when x is equal to 7. Okay? So to answer the question, which values for which values is the function continuous? So for x in or belonging to the set, let's write this in interval notation, minus infinite up to 0 round brackets because we don't include our endpoints, union, which is a gluing together of the two sets, 0 up to 7 but not including the endpoints, so round brackets, and then union 7 to infinite. Okay, so that's one way to write it, or you could say any real number except for the set containing 0 and 7 are fine as input elements of the function. Okay, let's move on to question 28. Oh, it looks like I've just done 28. Okay, so we're moving on to 29. So 29 asks us to calculate a limit. So what is the limit as x approaches 3 of 9x minus 16? Well, what you need to ask yourself is there ever any problem with substituting 3 in there? Right? And I can see the answer is no, because it doesn't create a 0 denominator. It doesn't create a negative inside this inside a square root, for example. And so when it's the case that we don't introduce any problems by just substituting that number in, then we do so. So we have 9 times 3 minus 16, and this is 27 minus 16, which is 11. Okay, so our limit is 11. Let's move on to question 30. Okay, in question 30, we have a limit as x approaches 5 of the square root of x squared minus 9. And so here, again, there's no problem with just plain subbing in that 5 because we have 25 minus 9, and that's positive, so that's fine. So we just sub this in, and we get the square root of 5 squared minus 9, which is the square root of 25 minus 9. And the square root of 25 minus 9 is 4, I think, because this is square root of 16, which is 4. So our limit is 4. Now, it doesn't always just mean to sub in. Let's have a look at question 31. In question 31, we're asked to take the limit as x approaches 0 of x squared plus x over x. Now, I need to tell you what this limit means, okay? But first, what would happen if we just substituted in 0 for the x? Well, you'd have 0 over 0. So in a little box over here, note 0 over 0 is not a number. Exclamation mark. Okay, so don't just sub it in there. So what this asks you is, what is the value of this function right here? Very close to 0. So to answer this question, let's consider the intuition on the problem. So let f of x be equal to x squared plus x over x. Okay, now what would happen if I substituted in to this function, say 0.01? F of 0.01. Okay, let's calculate this in Mathematica. So let's just build a function, f of x. What does it do? Well, the function takes in x squared, sorry, it takes in x and produces x squared plus x all over x. Okay, now what happens if I sub in 0.01? What do I get? I get 1.01. And is it exactly that? Yes. I get 1.01. Okay, now what happens if I sub in minus 0.01? What do I get? So f of minus 0.01 is 0.99. Now notice both of these are really close to 1. Okay, so what happens if I add another 0 here? F of minus 0.001 is equal to 0.999, also close to 1. And if I change the sign on this, f of 0.001 is equal to 1.001. Okay, so both of these even closer to 1. Okay, can I just put in 0? Let's see if Mathematica knows what to do. Okay, you see it complains about that because it gets 0 over 0, which is not defined. So the function is not defined at 0. Not defined at x equals 0, but is defined near 0. And that's what the limit asks you to calculate. But there's a special method to do this. So the way we do this in practice is not by calculating approximations to the function near 0. What we do is factorize the numerator and denominator and then simplify and then sub in once there are no problems. So x squared plus x factorizes as x outside of x plus 1, and that's over x. Okay, now we can cancel the x, and that's the part that caused the problem. So we've got the limit as x approaches 0 of x plus 1 over 1. And this limit is just 1 because when we sub in 0 into that x, we just get 1. Exactly as we expect here from looking at numbers that are really close to 0 as inputs, we get numbers as outputs that are very close to 1. Okay, so that's the meaning of your limit there. It tells you what's happening near the function, but not exactly equal to the function. Okay, question 32. So for 32, we want to evaluate the limit as x approaches minus 1 of x squared minus 1 over 3x plus 3. So look at this. If you just subbed in minus 1, you would have 1 minus 1 in the numerator, which is 0, and you would have minus 3 plus 3 in the denominator, which is 0. So you would have 0 over 0, which is not defined. So you need to do a cancellation first. So we keep writing limit, x goes to minus 1. We factorize our numerator, factorize the denominator, and then you cancel the common terms in the numerator and denominator. Okay, so we have this, and now there's no problem in subbing in that x is minus 1. So we have minus 1 all over 3, which is minus 2/3. Okay, and we don't write lib in here at this line because we've already subbed in that value of x. All right, next question. Calculate y dash for y equals 5x minus 2 using the limit definition. Okay, now I would advise you to do this using the rules of differentiation first and say we expect y dash to be equal to 5, okay, because the derivative of 5x is 5 and the derivative of minus 2 is 0, so we should get 5 for this derivative when we do this via limits. So let's go ahead and do this via limits. So via definition, we have f dash of x is equal to the limit as h goes to 0 of 1 on h f of x plus h minus f of x. Okay, so in other words, if we have some function like this and we want to estimate or calculate exactly the slope of a tangent at a given point, we can step forward h units to get to x equals x plus h, and then the corresponding y value is f of x here, and the y value of this is f of x plus h. Okay, so this is just rise over run here. X plus h minus x is h, that's our run, and the rise is f of x plus h minus f of x. But what we're doing in taking this limit as h goes to 0 is we're letting that h value get smaller and smaller until this distance approaches 0, and so this secant becomes an actual tangent, giving you the slope of this curve at the point. Okay, so that's why this works. Now let's actually calculate it in this example. So we have the limit as h goes to 0 of 1 on h. Now f of x plus h, what we're doing here is we're taking this function and replacing all of the x's with the x plus h. So 5x plus h minus 2, and then we subtract f of x. Be careful with the signs. Okay, now we just need to simplify this and cancel things. So we expand this. Okay, you can see that a few things vanish. 5x minus 5x is 0. Minus 2 plus 2 is 0. And so we have the limit as h goes to 0. 1 on h, 5h. Okay, now we can cancel the h's, and we have limit as h goes to 0 of 5, which of course is just 5. So we get what we expect. This 5 is the same as that 5. All right, moving on to question 34. Okay, y equals x squared minus 1, and we are to calculate the first derivative using the limit definition. So expect 2x, because that's our derivative of this. So y dash is equal to the limit as h goes to 0, 1 on h, y of x plus h minus y of x. Okay, so we've got limit as h goes to 0, 1 on h. Now we're replacing x with x plus h, so x plus h squared, subtract 1, and then minus x squared minus 1. Next we expand. So we get x squared plus 2xh plus h squared for the expansion of that square, minus 1 minus x squared plus 1, because minus minus 1 is plus 1. Now let's have a look at what vanishes. X squared minus x squared, that vanishes, and minus 1 plus 1 vanishes. So we're left with 2xh plus h squared. Okay, now we need to factorize the h out of this expression in the numerator. So we have 2x plus h outside of h. Okay, now we can cancel this with this, and so we've got the limit as h goes to 0 of 2x plus h. And so we get 2x plus 0, which of course is 2x, matching what we expect up here, that 2x. Okay, let's move on to the next one. Question 35. Y equals x cubed plus 4x minus 3 pi. Okay, we've got to do the same thing, calculate the derivative using the limit definition, but we expect 3x squared plus 4, because that's our derivative there. Okay, so y dash of x equals the limit as h goes to 0, 1 on h, y of x plus h minus y of x. Okay, replacing x plus h where all the x's are there. And then let's subtract y of x, which is this. So minus x cubed minus 4x, and that would be plus 3 pi. Okay, now we need to expand this cube. So remember Pascal's triangle. Okay, where to get this, I add the two of these, but we're interested in this row here, right? Because this tells us how to expand a sum to the power of 3. So in other words, x plus h all cubed is x cubed plus 3x squared h plus 3 x h squared plus h cubed. So I have coefficient 1, 3, 3, 1. Okay, so that goes in there. X cubed plus 3x squared h plus 3x h squared plus h cubed, and then the expansion of this is 4x plus 4h. These cancel. Then we have minus x cubed minus 4x. Okay, let's let these vanish. X cubed minus x cubed is 0. 4x minus 4x is 0. So we have the limit. H goes to 0, 1 on h. 3x squared h plus 3x h squared plus h cubed plus 4h. Okay, now we need to factorize the h out. We're left with 3x squared plus 3xh plus h squared plus 4. Okay, cancel the h, and then we just have the limit. As h goes to 0 of 3x squared plus 3xh plus h squared plus 4. So now we sub in h is 0, and we have 3x squared plus 0 plus 0 plus 4. Of course, that's 3x squared plus 4 as we expect. Okay, good. Let's move on to the next one, question 36, which says calculate for the curve y equals 3x squared minus 2x, calculate y dash, and evaluate at the point minus 1, 5. Okay, so our first derivative, y dash as a function of x, is 3 times 2, x to the power of 2 minus 1, minus 2, bringing down the exponent 1, times 1, x to the power of 1 minus 1. So we've got 6x to the 1 minus 2 times x to the 0, but x to the 0 is 1. So we've just got 6x minus 2 as our first derivative. Now it says to evaluate it at the point minus 1, 5. So what we need to do is evaluate y dash of minus 1. And so we just replace x with minus 1. So we've got minus 6 minus 2, which is minus 8. All right, let's move on to question 37. At what point on the curve y equals 2x squared minus 16x is there a tangent that is horizontal? Okay, so when is the tangent horizontal? So we calculate the first derivative, and we get 2, bringing down that 2 times 2 is 4, x to the power of 2 minus 1 is 1, the derivative of minus 16x is minus 16, and when is this horizontal? Well, when it's 0, when that slope is 0, and we've got to solve this equation for x. Okay, so solving for x, we have 4x is equal to 16, divide by 4, and we get x is equal to 4. Does that answer the question? At what point? Okay, so we've got an x value, we need a y value. So we then sub this 4 back into the function. So y of 4 is equal to 2 times 4 squared minus 16 times 4. Okay, so this is 2 times 16 is 32, and then 16 times 4 is 64. So we've got minus 32, and the point is the point 4 minus 32. Okay, let's move on and do another example. Question 38. Find the derivative of y equals x to the power of 8. So we pull down the 8 from the exponent and subtract 1 from the exponent. So we have 8x to the power of 7 as our first derivative. Okay, question 39. Differentiate or find the first derivative of f of x equals minus 4x to the power of 11. So here f dash of x is minus 4 times 11 x to the power of 11 minus 1, which is minus 44 x to the power of 10. Okay, question 40. Find the derivative of y equals 5x to the 4th minus 3 pi. Okay, we bring down the 4. 5 by 4, x to the power of 4 minus 1, and the derivative of minus 3 pi is 0. So we have 20x cubed. Okay, question 41. Find the derivative of this function p equals 5r cubed minus 2r plus 1. So p dash as a function of r is 5 times 3 is 15, r to the power of 2, subtracting 1 from that exponent. The derivative of minus 2r is minus 2, and the derivative of 1 is 0. So we're done with that question. Let's move on to 42. Find the derivative of y equals 6x squared minus 8x plus 1 at the point 2, 9. Okay, the first derivative, bring down the 2, so we have 6 times 2 is 12, x to the power of 2 minus 1 is 1. The derivative of minus 8x is minus 8, so there's our first derivative. Now we want to evaluate this at the point 2, 9, so y dash of 2 is equal to 12 times 2 minus 8, which is 24 minus 8, and that is 16. All right, question 43. Find the derivative of y equals 2x cubed plus 9x minus 7 at the point minus 2 minus 41. Okay, differentiating this, we have y dash of x is 2 times 3 is 6, x to the power of 2 plus 9. Now we evaluate this at 2, so 6 times 2 squared plus 9. 6 times 4 is 24. 24 plus 9 is 33. Okay, so that brings us to question 44. Find the slope of the tangent of the function y equals 35x minus 2x to the 4th when x is 2. Okay, so the slope of the tangent is the slope of the function. So y dash of x is 35. 2 times 4 is 8. So we have this is our first derivative. Now y dash of 2 is equal to 35 minus 8 times 2 cubed. 2 cubed is 8. So we have 35 minus 64, which is minus 31, is it? So I'm just a little bit brain dead at the moment, so I'll open up my calculator window. Okay, 35 minus 64 minus 29. Okay, let's move on to the next question. 45. Find the derivative of y equals 6 root x. Well, you want to write this as 6x to the 1/2. So y dash of x, bring down the half. So 6 times 1/2. Subtract 1 from the exponent. And 6 divided by 2 is 3, so we have 3 x to the power of minus 1/2, and we can write this 3 over the square root of x. Okay, question 46. Find the first derivative of v equals 3 over 5t cubed, which you want to write as 3/5 t to the power of minus 3. And now to differentiate this, you bring down the minus 3, so 3/5 times minus 3 times t to the power of minus 3 minus 1. So we've got minus 9 over 5 t to the power of minus 4. Okay, let's move on to question 47. Y equals 3 over the cube root of x plus 4x squared. Okay, calculate the first derivative of this. So we want to write this as 3x to the minus 1/3 plus 4x squared. So then y dash of x, we bring down the minus 1/3, subtract 1 from the exponent. Same thing here, 4 times 2. Subtract 1 from the exponent. Simplify this, we cancel the 3's, and so we have minus x to the power of minus 4 over 3, and then plus 8x to the power of 1, which is 8x. Okay, question 48. Find the derivative of x, root x, minus 6 over x. So we want to write this one as x to the power of 3 over 2. Remember, root x is x to the half, and we add the exponents. 1 plus 1/2 is 3 halves. And then minus 6x to the minus 1. So y dash of x is equal to 3 halves x to the power of 3 over 2 minus 1. Then minus 6 times minus 1, x to the power of minus 1 minus 1. So we have 3 halves x to the power of 1/2 plus 6 x to the minus 2. And if you want to, you can write this as 3 halves root x plus 6 over x squared. Okay, question 49. Find the derivative of f of x equal to 2x to the minus 3 minus 3x to the minus 2. So f dash of x is 2 times minus 3 x to the power of minus 3 minus 1 minus 3 times minus 2 x to the power of minus 2 minus 1. And this is minus 6 x to the minus 4, and then plus 6 x to the minus 3. Okay, question 50. We've got y equals x cubed plus 7x squared, and we've got to calculate y dash and y double dash. Okay, y dash equals 3x squared plus 7 times 2 x to the power of 1, which is y dash equals 3x squared plus 14x. Okay, now y double dash is the derivative with respect to x of y dash. And so differentiating this again, we've got 3 times 2 x to the power of 2 minus 1 plus 14 times 1 x to the power of 1 minus 1. And so we just have 16x plus 14. Okay, question 51. Y is equal to x cubed minus 6x to the 4th. We've got to calculate y dash and y double dash. So y dash is 3x squared minus 6 times 4 is 24 x cubed. Y double dash, differentiating this again, we have 3 times 2 is 6, x to the 1. 3 times 24 is 72, x squared. Okay, question 52. Y is 2x to the power of 7 minus x to the 6 minus 3x. And we've got to find y double dash. Okay, well, we need to find y dash first. Bring down the 7. 2 times 7 is 14. X to the power of 6 minus 6x to the 5th minus 3. There's our first derivative. And now we need to differentiate this again. So 6 times 14 is 60 plus 24. Which is 84. x to the power of 5. 6 times 5 is 30. We have x to the power of 4, and the minus 3 goes to 0 when we differentiate. Okay, so I think this is the last one. Question 53. Y equals 2x plus root x, which we want to write as 2x plus x to the 1/2. And we've got to find y double dash. Okay, so let's differentiate this. Y dash is 2. Bring down the half. So plus 1/2 x to the power of 1/2 minus 1. So we have 2 plus 1/2 x to the minus 1/2. Now the second derivative, y double dash, is the derivative of this derivative. The derivative of 2 is 0. And so we now differentiate 1/2 x to the minus 1/2. We bring down the minus 1/2. So 1/2 times minus 1/2 x to the power of minus 1/2 minus 1. And so we have minus 1/4 x to the power of minus 3 over 2. Okay, and we finished. Thank you.